You know the moon. You've looked at it your whole life. Full moon, half moon, crescent. It hangs up there every night. The same familiar shape, the same reliable presence. Earth has one moon. Everyone knows that. It's in every textbook, every classroom poster, every conversation about space you've ever had. Except it's not true. Earth has more than one moon. It has always had more than one moon. Scientists know this. It's documented, peer-reviewed, and sitting in publicly accessible research that anyone can read. And yet somehow, in all the years you spent learning about space, the solar system posters, the school projects, the documentaries, nobody mentioned it. Not once. Before you assume this is some fringe conspiracy or a technicality so minor it doesn't count, one of these objects has been silently orbiting Earth for over a century. It was there before your grandparents were born. It will be there long after you're gone. And a major space agency is currently building a mission to go visit it, specifically because of how strange it is. Its name is Kamo'oalewa, and it is right now following Earth through space like a shadow. To understand what this actually means, you first need to understand what a moon really is. And here's where it gets complicated, because the scientific community doesn't have a clean, universally agreed definition. We know what our moon is: a large, spherical body gravitationally bound to Earth, in a stable orbit, massive enough to have formed into a ball under its own gravity. But that definition, applied strictly, excludes a huge number of objects that behave almost exactly like moons in every practical sense. Objects that follow planets. Objects that travel with them. Objects locked into long, synchronized gravitational dances that have lasted for decades, centuries, or longer. The definition of what counts is where the argument starts, and it's an argument that changes what you think you know about your own planet. Let's start with the one that broke the internet when it was confirmed in 2016, even though almost nobody outside of planetary science noticed. Kamo'oalewa, designated 2016 HO3 before it got its official name, is a small asteroid, somewhere between 40 and 100 meters wide. Not huge, not planet-sized, but it has been locked into a synchronized orbit around the Sun that keeps it perpetually close to Earth, looping around our planet in a slow, stable spiral that repeats every year. It never gets closer than about 38 times the distance to the Moon. It never drifts farther than about 100 times that distance. It stays in this exact range, following Earth like a companion, never escaping, never falling in. Scientists call this a quasi-satellite orbit. It isn't gravitationally bound to Earth the way our Moon is. It's technically orbiting the Sun. But Earth's gravity shapes its path so consistently, so completely, that the result is functionally identical to a moon for all practical purposes. It follows us. It has been following us for roughly a century already. Models suggest it will keep following us for at least another 3 centuries before the orbital mechanics eventually shift it out of this pattern. For 100 years, Earth has had a companion in space that nobody on the surface knew about. But here's the detail that genuinely unsettled planetary scientists when they looked more closely. Kamo'oalewa reflects light differently than most asteroids. Its spectral signature, the way it absorbs and bounces back sunlight, matches lunar silicate material. Rock from the Moon, not typical asteroid rock, not the composition you'd expect from something that drifted in from the asteroid belt. The leading hypothesis currently being investigated is that Kamo'oalewa is a fragment of our own moon, a chunk blasted into space by an ancient impact, captured into this strange companion orbit, and quietly following Earth ever since. A piece of the Moon, orbiting Earth, for a century, unannounced. China's Tianwen-2 mission is scheduled to visit it and bring back a sample. If the analysis confirms lunar origin, it means Earth's second moon is literally made of its first one. Kamo'oalewa isn't the only one. In 1986, astronomers discovered an asteroid called 3753 Cruithne. It's about 5 kilometers wide, small, dark, and traveling on one of the strangest orbital paths ever mapped in the inner solar system. Cruithne follows a horseshoe-shaped orbit relative to Earth, swinging in close, curving away, looping back, and repeating the pattern on a cycle that takes roughly 770 years to complete one full horseshoe. It never collides with Earth. It never escapes. It just keeps tracing the same enormous curved path, locked in gravitational step with our planet, technically orbiting the Sun but functionally tethered to Earth in a way that no other large object in the solar system is. For a while, popular science writing called Cruithne Earth's second moon. Then other researchers objected. Technically, it's not gravitationally bound to Earth. Technically, the horseshoe classification puts it in a different category. Technically, the word moon implies something more permanent. The argument over terminology went on long enough that most science communicators quietly stopped covering it to avoid the debate, and Cruthon dropped out of public awareness entirely. Most people alive today have never heard of it. Then, in 2020, astronomers confirmed something even stranger. An object called 2020 CD3, roughly the size of a car, had been captured by Earth's gravity and was genuinely orbiting our planet. Not a quasi-satellite, not a horseshoe companion, an actual temporary moon, gravitationally bound to Earth, looping around it on a real lunar orbit. It had been there, undetected, for roughly 3 years before anyone noticed, and by the time it was confirmed and announced, it was already leaving. Earth's gravity eventually lost its grip, and 2020 CD3 drifted away and continued its path around the sun. Earth had a moon. It arrived silently. It left silently. We almost missed it entirely. Here's the part that reframes everything. These objects, Kamo'oalewa, Cruthon, 2020 CD3, and the handful of other quasi-satellites and temporary captures that have been documented over the years, aren't anomalies. They're not weird exceptions to an otherwise clean picture. They're what planetary scientists now expect to find around any large body in the inner solar system that's had billions of years to accumulate gravitational companions. The real anomaly isn't that Earth has multiple objects following it. It's that we spent so long assuming it didn't. The reason the textbooks say one moon is partly definitional and partly historical. When the definition of moon was being standardized, it was built around the only example anyone had studied closely, our moon. Large, spherical, tidally locked, geologically distinct, visible to the naked eye. The definition was shaped by the object, not the other way around, and anything that didn't match those specific characteristics got quietly filed under a different category: quasi-satellite, co-orbital companion, temporary capture, different words for objects that are, in every meaningful sense, doing what moons do, following a planet through space indefinitely. The moon itself, by the way, is already one of the strangest objects in the solar system, and most people don't know that either. It is enormous relative to Earth compared to any other planet-moon pairing in the inner solar system. Mars has 2 tiny captured asteroids that barely qualify. Venus has none. Mercury has none. Earth has this massive, geologically complex, nearly planet-sized object locked in a precise orbit, and nobody has a completely clean explanation for how it got there. The leading theory is that a Mars-sized body called Theia collided with early Earth about 4.5 billion years ago, and the debris coalesced into the moon. It's the best model available, it fits most of the evidence, but it requires a collision so specific, so precisely angled, so perfectly calibrated in speed and mass that some researchers still find the probability uncomfortable. Earth's main moon is a mystery. Its second moon might be a chunk of the first one, and more companions are probably out there, too small or too dark to have been found yet. So why didn't anyone tell you? Part of it is the definition problem. Scientists genuinely disagree on what counts, and science communicators avoid topics where the terminology is contested because it generates more argument than understanding. Easier to say one moon and move on than to spend the whole lesson debating orbital classifications. Part of it is detection. Kamo'oalewa is 40 to 100 meters wide and hundreds of times farther away than our moon. 2020 CD3 was the size of a car. These objects are nearly impossible to spot without dedicated sky surveys running specifically to look for them. Most of the sky survey infrastructure that could detect them has only existed for a few decades. The objects themselves might have been there for centuries before we had the tools to find them. We haven't been missing them because they were hidden. We've been missing them because we were barely looking. And part of it is that the story of the moon, the one moon, our moon, hanging up there every night, is so embedded in human culture that there's almost no space for the more complicated version. Every language on Earth has a word for the moon. Every calendar system in history has been built around it. It's in mythology, religion, poetry, navigation, and biology. The idea that there are other objects quietly following Earth in the dark, that we've been a multi-moon system for longer than recorded history, that a chunk of our own moon might be orbiting us right now. It doesn't fit the story we've been telling ourselves. But the sky doesn't care about the story. Kamo'oalewa is up there tonight, the same place it's been for 100 years, following Earth through space, slowly, silently, made of the same rock as the thing you look at every night, a ghost of the moon, trailing behind us in the dark, completely unannounced. You just didn't know to look for it.